My name's David Steele. I'm a product manager here at Arcturus. Today what I'm going to show you how to do is to use some of the advanced voice over IP options that are available in our voice and media middleware. So the page that you're looking at right now is the web user interface to one of our devices running our software. It's the UC53281 embedded voice module. So all we need to do to log in is just enter the IP address in the URL line of your browser, then click login and enter the username admin and the password admin. That'll bring you to the home page, which, as you can see, this device already has an account on it. I'm just going to click on the Voice over IP tab, and then I'm going to that brings us to the account information. Then I'm just going to click on Options, and this brings up a page which has some advanced configuration parameters. They include flash times, so if your device has an FXS port attached to it that uses a SLIC, you can configure the flash timing. It also includes caller ID disable, so that will substitute anonymous in the call ID field. And it also includes some advanced call blocking rules as well, which allows you to configure based on area code or exchange certain rules to restrict outgoing calls. Some of the other options that are available as advanced options are also the audio settings. So we just click on Audio on the left-hand column bar. This brings us up to a page that has the configurable codec selection. So this device supports a variety of codecs: G711A law, U law, ILBC 729, and G722. You can configure your audio settings and the codec you wish to use by selecting them from the drop-down box and then clicking Apply. As you can see, I'm using G711 right now, which is a typical telephony codec and supported by most devices. The silent settings allow you to either suppress or transmit silence in the RTP media stream and require the support of the codec. These are the receive and the transmit volumes. So receive turns the volume up on your headset that would be connected to the device. The transmit volume turns up the gain on the microphone. The jitter compensation is a buffer that takes incoming RTP or real-time media packets and allows them to be reassembled in the right order. So we've got a 30 millisecond buffer set up. DTMF can be configured to be sent via RTP, which means that it'll get created as a DTMF packet, or in-band via audio, which means that it will send the tone and audio. The intercom answer settings and auto answer times are two configurable options used for intercom type devices. So push-to-call applications or building intercoms or rescue assistance buttons, for example. If I change the intercom answer setting to 2, it means the device will auto answer itself. So if I were to call it, it means it will go off hook right away. If I change the answer time, it means it will wait for either 1, 2, 3, or 4 seconds, or up to 20 seconds. Before it answers. Auto hang-up means that once the call has completed, auto hang-up, if enabled, will hang up the call itself. Local DTMF tones means it will either play or not play the tones as they are created on the device. So when I dial from the device out, I can either hear the DTMF tones that are being played, or I can suppress the DTMF tones so it sounds silent. Let's go on to the AEC, or the Acoustic Echo Canceller. The Acoustic Echo Canceller is intended for devices that have both an amplified speaker and a microphone, so applications like speakerphones or intercoms. The purpose of the Echo Canceller is to try to minimize background echo and improve the quality of the audio. There are several configurable parameters, including an enable or disable, which turns on or off the AEC component. There is also an adaptation enable-disable. The adaptation component constantly tunes the AEC algorithm for changing acoustic properties. There is a configurable echo tail length, which controls the length of time that the algorithm will process and cancel echo. There's also a gain pad. This is used to bring the RX and TX audio path levels close to each other so that the algorithm can perform most optimally. And there's an NLP control. This is a nonlinear processing element of the algorithm. It's also called crosstalk control. And finally, there's also a buffer offset function. The buffer offset function assumes at time 0 that there is no echo, so it can start the algorithm later and expand the tail length in 10 millisecond buffer lengths.